What is radio astronomy? A subfield of astronomy that studies celestial objects at radio frequencies. The initial detection of radio wave from the astronomical object was created in the 1930s. The invention of the cosmic microwave background signal, thought to the proof for the Big Bang theory, was created through radio astronomy. Radio astronomy is conducted using giant radio antennas named as radio telescope. They are either used singularly or with the multiple connected telescope utilizing the techniques of radio interferometry and aperture synthesis. Next, what is telescope? A tool that astronomers use to see faraway objects. Most telescope and all large telescope work by using curved mirrors to gather and focus light from the sky. So the bigger the mirror the lenses, the more light the telescope can gather. Light is then concentrated by the shape of the optics. That light is what we can see when we look into the telescope. So the telescope made with lenses is called refracting telescope. A lens bends the light passing through it, and then this makes things less blurry, and in telescope it makes far away things seem closer. Let's move on to the example of space telescope. So such as the Hubble Space Telescope and the Spitzer Space Telescope allow us to capture views of galaxies and nebulas far away from our own solar system. What is the meaning of celestial object? A celestial object is object that astronomers observe in outer space, either within our solar system or outside of it. Celestial bodies are sometimes called astronomical objects, celestial body, and heavenly bodies. For example, stars, planets, moons, asteroids, and even galaxies.
So now I will explain how does radio astronomy related to telescope. So why do we need a telescope? As a human, we have a limitation that we cannot know what is exactly happening at our space. So by using this telescope, it can help us to know what is actually happening at our space, outer space. So the first telescope that we're going to talk about is radio telescope. How does this radio telescope work is by detecting and amplify radio wave from space, and it will turn the radio wave to a signal that our astronomer can understand. So the astronomers can detect the radio wave from millions of light years from the Earth, which is it can help us to know what is happening, even though it is far away from our planet Earth. And if you look at the picture, the radio telescope, the circle shape, or we call it as a dish surface, it act like a smooth mirror, which is it will reflect back the upcoming radio wave from the space, and when it reflected it will reflect it into the one point at the telescope focus cabin. So the next one is optical telescope. Okay, optical telescope, we use it to collect the wavelength of visible light, but by using this telescope, we cannot get the whole image of the space. So the astronomer needs to repeat the procedure for a few times and combining the picture that they get to know the whole image of the space. And this type of telescope, how it works by adapted to the various electromagnetic spectrum frequencies, and can uncover hiding a space object like stars. And for information, the radio telescope needs to be more larger than the optical telescope because the wavelength of radio wave is much larger than the wavelength of visible light.
Hi, my name is NURAIN. So today I will present about what is the use of the telescope. My first point is the advancing the understanding of the universe. One of the primary purposes of the telescope is to conduct scientific research on celestial bodies. Astronomers use telescopes to observe stars, planets, galaxies, and other objects to gather data and insights into the nature of the universe. My second point is the unraveling the secrets of exoplanets. Telescopes play a crucial role in the discovery and study of exoplanets, where planets located outside our solar system. By monitoring changes in light as the exoplanets transit their host stars, scientists can infer valuable information about the atmospheres, compositions, and potential habitability. Telescopes equipped with spectrographs allow the researchers to analyze the chemical makeup of exoplanet atmospheres, offering clues about the potential to support life. And my third point is the mapping of the universe, which is galaxy formation and evolution. Telescopes contribute significantly to our understanding of galaxy formation and evolution. Through deep sky surveys, astronomers can analyze the distribution of galaxies in the universe, discern patterns of clustering, and uncover the large-scale structure of cosmic web. This information helps us comprehend the forces shaping the universe on the grandest scales. Okay, next is the advantages of using telescope. A telescope that allows a camera to be attached offers the advantage of capturing detailed photographs of celestial objects. These setups enable high-resolution imaging of distant stars, planets, and galaxies, which is not possible with a camera alone. Then, telescope can be viewed even with the low intensity of light. This is because they collect and focus more light than the human eye, allowing them to capture faint objects and details that would otherwise be invisible. This is achieved through larger apertures and advanced optics, which enhance their light gathering and resolving power. And then, disadvantages of using telescope. A telescope needed frequent maintenance. Maintenance interruptions can also limit observation time, reducing the overall efficiency and productivity of astronomical research. And the last point is the main disadvantage of non-portable telescopes is that they are often large, heavy, and cumbersome, making them difficult to transport and set up. This limits their usability to fixed locations and reduces the flexibility for astronomers who want to observe from different sites or travel with their equipment.
This is example achievement of radio telescope that I found. The first one is clocking the crab nebula planet. Astronomers originally thought that a brightly blinking stars called pulsar, discovered in 1967, might be blasting white dwarf stars. But in 1968, Archivo saw the pulsar at the center of the Crab Nebula flashing every 33 milliseconds faster than white dwarf can pass it. That discovery stated the idea that pulsars are actually rapidly spinning neutron stars, stellar corpus that sweep beams of radio wave around in space like celestial lighthouse. The second is ice in Mercury. Mercury seems like it would be an unlikely place to find water ice because the planet is so close to the sun. But Archivo observation in the early 1990s hinted that ice could impermanently shadow craters at Mercury poles. NASA Messenger's spacecraft later confirmed those observations. Finding ice on Mercury raised the question of whether ice might exist in shadow craters on the Moon too, and recent spacecraft observation indicate that it does. The last one is repeating radio blasts. Fast radio blasts, or FRB, are brief, brilliant blasts of radio wave with unknown origins. The first FRB known to give off multiple blasts was FRB 121102, which Archivo first spotted in 2012 and again in 2015. Finding a repeating FRB ruled out the possibility that these blasts were generated by one of cataclysmic events such as stellar collision, and because FRB 121102 kept recurring, astronomers were able to trace it back to its home, a dwarf galaxy about 2.5 billion light years away. This confirmed the decade-long suspicions that FRB come from beyond the Milky Way. The next slide is how to make image with a radio telescope. Radio telescopes are just like optical telescope in that the part of this telescope that produce image are actually the detectors that are placed at the focal point. Optical telescope use array detectors such as charge coupled device (CCD). Radio telescope can also use array detectors to produce image, but these array detector systems are often much more complicated and difficult to make. The most straightforward way to make a radio image with your satellite antenna system then is to use array detector, which I believe would be very difficult to find. Alternately, one can make an image by pointing an antenna to an array of nearby position on the sky, then creating a contour map of the measured signal straight. This is a rather slow process through that only produce an image much later. After you have created all your individual pointing measurement, remember too that you can do quite a few interesting measurements with your satellite antenna and receiver system.
Radio telescope has unique capabilities that allow us to observe and analyze celestial phenomena that are otherwise invisible to optical telescope. The future prospects for radio telescope are vast, driven by technological advancement and expanding scientific objectives. Here are some points radio telescope will play a crucial role. Firstly, studying cosmic phenomena allow us to detect the faint signal from the early universe, providing insight into the information of the first star and the galaxy. They help us understand the approach of ionization and the condition that led to the universe we see today. We're also able to investigate dark matter and dark energy by mapping the distribution of galaxy and cosmic structure. Radio telescope contribute to our understanding of the dark matter and dark energy, which constitute most of the universe's mass energy content. Secondly is mapping the cosmic background, which is a study about the afterglow of the Big Bang, and radio telescope are critical for the studying its functioning. This research helps us refine our model of the universe's origin, composition, and evolution. Next is exploring exoplanets and the search of extraterrestrial life. Radio telescope can detect the magnetic field of exoplanets, providing clues about their habitability and magnetic environment. Advance in technology will enhance our ability to detect the signal if they exist. Last but not least, observing pulsar and black holes. Radio telescope can precisely measure the timing of pulsar, whether it's highly magnetized or rotating neutron star. This can test the limit of general relativity, and potentially detect gravitational wave. Black hole image produce the first image of black hole event horizon, and this feature improvement in this network will provide more detailed image and deeper insight into black hole physics. In conclusion, the future of radio telescope is promising, with many exciting projects and advancement on the future. This instrument will continue to deepen our understanding of the universe, addressing fundamental questions about its origin, structure, and the functional potential of life beyond Earth. As technology progresses, radio telescope will become more powerful, opening new frontiers in astronomy and cosmology in the future.